Okay, let's learn about the descriptive statistics in this lecture. Let me import a file in Excel form which is saved on my system. It says descriptive. Descriptive file. Okay, let me change the name here to data file. If you remember, in the first video, we worked on the same file. I'm importing it. Okay. Now let's start working. So it has serial number, weight, height, age, gender, and treatment. We used few functions like null function to remove the column, and another thing we did in this file was we changed the names of these columns. Let us handle this data and learn descriptive statistics about it now. First, I want to learn about the measures of central tendency. We know that we have main measures of central tendency, mean, median, mode. So but before that, I want to avoid any missing value if there is any, so that I can calculate easily the other things. So to avoid missing value, I am writing from data file dollar. I want from gender, I want values, any values to omit. So it will be na dot omit. क्या omit करना है? Data file से gender column में any values. Okay. Now I want to remove and these missing values, any values from other columns also. So I can do the same thing. Data file. Let's say now I want to remove from weight any dot omit. If you remember this command, we used it before also. Data file dollar. Now I want to remove from the weight. I'm running this command. Okay, so similarly we can remove from all the columns, but we have to write again and again data file. So to avoid this also, writing it again and again, I am just using one function attach. So I am attaching my data file here, and now I don't running this command. Now I don't have to uh, write this again and again. I can directly write the column name. For example, age, na dot omit age. Okay. Similarly, so we can remove missing values like this first. And now let's start with the summary of this. Summary of data file. Okay. If I want all the summary at one go, I can simply write summary of data file. It will give me everything for every column. You can see here in the output for SN, this was just the serial number. I did not remove it this time, but it has no relevance. Look at the weight. minimum weight, first quartile, median, mean, third quartile, maximum. Then similarly, it has given me for height, age, gender, treatment for every column. Okay. If I want individual summary, so I want summary of, first say let's age. Now it is giving me only age. If I want summary of height, it will give me the summary of height. You can see summary of height. This was written by mistake. This is the summary of height. So similarly, we can calculate summary, mean, weight. Okay. Now I want measures of central tendency. So we generally calculate measures of central tendency. We calculate mean. If I want mean of the all the columns, I can calculate. If I want mean of a particular column, I can calculate mean. Let's say I want for weight. I'm running this command. This is mean of weight. I want median of height. Simple command is median height. Okay. Now let us see. This was measures of central tendency. Now let us see measures of dispersion. Measures of dispersion. Dispersion means it tells us how far our values are from the average, mean value, center value. So there are three ways where we can calculate measures of dispersion. One is range, then variance, and then standard deviation. Standard deviation is the most common one. Okay, let's see if I have to calculate range of weight. See, what we have to do, we just have to rewrite weight now because we have already attached the file. So I'm just running this command. It is showing 50.8 and 99.1. So it shows us, the spread. The minimum value is this and the maximum value is this. Otherwise, if we would have not attached the data file, हमें सबके साथ ऐसे लिखना पड़ता range data file and then dollar value and whatever column we want. But since we have attached data file now, we can simply write all the commands. Okay, now I want to calculate, for example, variance. So before calculating variance, we have formula VAR, this is the syntax, and I want to calculate variance for age. So it says variance is 158.9378. But this is, I told you, this measures of dispersion shows us how far the data is from the average, from the mean. But this is in squared units. So we can calculate standard deviation also. Standard deviation syntax we use SD. Okay. Now SD, this is the most widely used and this is the square root of variance. So I am calculating for the same standard deviation of age. So this is coming to be 12.60. Okay, we can run the normality test also for normality test whether our data is normal or not. We can discuss in detail about normality later on, but we have few methods. One of the common methods is Shapiro. So I'm just Shapiro test of, for example, I want to calculate it for weight. Okay, so p-value shows non-significant. Now let us try a summary of group by. Let us learn about one small function which is apply function in this R. That is very useful. If I don't want a summary or the mean um, of one particular column, I want it in relation to something. So let us see. I want summary of weight by age. Okay. So what will I do? I will apply T apply function. T apply. Now I have to put vector here. मुझे कौन सी वेक्टर चाहिए? वेट. वेट वेक्टर मीन्स कॉलम. मुझे वेट कॉलम चाहिए और अकॉर्डिंग टू एज चाहिए है ना. और यहाँ फंक्शन में आई विल राइट समरी. सो मुझे समरी चाहिए वेट की, लेकिन एज के बेसिस, एज के अकॉर्डिंगली. लेट मी रन दिस कमेंट. ओके, सी दिस. Now let us see again. I want summary of weight by gender. According to gender I want. So I will apply T apply here. Now I want weight. We all know that weight is dependent on somehow age, gender also. So I want weight according to gender and I want the summary. Okay, earlier there was some mistake. I'll correct it, but this is the correct one. It is showing me the weight as per gender, female. Can you see? Minimum is this, maximum is this. Then male, in among males, minimum weight is this, median is this, mean is this, maximum value is this. So this is how we can do group wise. Let me do this again. Weight according to age. No, okay, according to age it is showing like, because different ages are there, so it is showing me all. If I do it according to what was the last treatment, there are three kind of treatment or groups. Let me see by group. Object group not found in the data file. Was it grouping? No, it was treatment. I'm sorry. Now you can see as per the treatment A, group A has these statistics, group B has these statistics, and group C has these statistics. Okay, let us learn about, so till now we talked about total summary, then measures of dispersion, measures of central tendency. Now let's see the relationship between the variables, and we know to see the relationship between variables, we use covariance, correlation, or we can say co coefficient of determination also. So three things are there to test the relationship between two variables or three variables. If I want to check correlation, okay. So now I want correlation between weight. Mind it, if you have not attached the file before, so in everywhere you will have to write data file and then dollar sign and the column name. Since I have attached the file, I am writing these directly. So I want the correlation between weight and gender. Okay. Okay. Why must be numeric? We cannot apply, sorry, correlation on. I want to on numerical categorical data. I want to see correlation of weight and height. See, it is showing us this correlation, and the significance of correlation we know it is whether it is moderate, high, or low. Similarly, I can calculate covariance. Let's say I want to calculate covariance between weight and height. So for covariance, I have COV. It has to be between the numeric vectors. Okay, so the covariance is this. I can calculate coefficient of determination also. Coefficient of determination is nothing but the square root of correlation. Weight, I want to calculate between weight and height only. Square root, we use cap for this. So this is the not square root, power square of this correlation. Okay, so to test the relationship between variables, we use three methods. Most popular is correlation. We see correlation, we can see correlation, covariance, coefficient of determination. Okay, now if I want to see the correlation of three variables, so what I have to write pairs. Okay, in pairs, I want the three variables. I'm putting this three variables, that is weight plus age plus height. Okay. You can see the correlation between these three variables here, weight, age, and height. Now, let us see, in the last session, we talked about visualization. So if I want to make histograms, you can make anything, line, graph, scatter plot, box chart. We learned everything. So I want the histogram of weight. Okay, can you see histogram of weight? I want the histogram of height. This is the histogram of height. I want the histogram of age. How do we give the command for histogram? Hist, H-I-S-T. So this is the histogram of age. Now, if I want all the histograms to be displayed at one place, let me see. Let me copy this command and write it again. So before this, I will use the function par. Let me write it here so that it is clear. Okay, I want all this. I have, this say set or query graphical parameters. So I am writing this. I will use this function par m f row, okay, equals to combine value. I want this. Let me run this command. A minute. This is complete. Okay, let me run this entire command at once. Okay, can you see all these histograms at one place? Okay, now I want to first say give a color to these histogram also. So along with weight, uh, for weight I want to give it a color red. Height I want to give it a color yellow. And for age, I want to give color blue. Okay. Let me run this command now. So see, this has changed. Okay. So again, we learned about measures of dispersion, relationship between variables, and little bit of visualization we can do like this. Everything we can make. We have learned about how to give headings to this, how to label x-axis and y-axis, and everything which we did in the last session. Coming to the last part of this descriptive statistics, let us learn about regression here. Okay. Now, there is s- two types we will be doing under regression. One is simple regression, where we see the we see where we can see the predictive values of one variable depending on another, and we can see multiple regression variable uh, model also, where we can predict, you know, for example, weight using height and age. So more than two variables are involved. Let us see regression, simple regression first. I want, for example, let's say I'm giving this name model 1. Okay, simple regression model 1. I want, I'm giving the command lm. Here I'm seeing weight depending on, uh, for since weight depending on height, I'm using one symbol tilde, this one above the tab key. So this means it depends on weight depending on height of, just give me a moment. Okay, we were seeing this simple regression. So I want weight depending on height of my data. My data is data file. Okay, now I'm running this command. Now I want the summary of this. So I'm writing summary of model 1. Model 1 name I gave to my, can you see? It has given everything. Residual, standard error, coefficient, intercept, height. So I think these statistics things and we have discussed also. Now, now let me make another model, which is model 2 for multiple regression. Model 2 LM. Now I want weights. Was it weight or weights? Okay. Weight depending on tilde height plus age. My data is data file. Sorry. I'm running this command and now I want to see the summary of my model 2. So I got this model 2 and this is multiple regression where we saw weight, we saw prediction of weight depending on height and age both. In simple regression, we saw the predictive value of prediction of weight based on height. Okay, so this is about descriptive statistics and that's it. Thank you.